So thank you very much for coming along to .NET Knots. So I can get my slides to change. Before we get going, we've got a code of conduct in place for this group generally. You'll see all of the groups I run will have a code of conduct similar to this. There's lots of words on there, but really the bottom right-hand corner of that says be kind and considerate sums it up nicely. If anybody feels as though they've been made to feel uncomfortable or somebody is breaking our code of conduct, then send either Connell or myself a direct message in the Zoom chat, and we'll endeavour to put all things right and make sure that you're kept fully up to speed with what's going on there. But we run a nice meetup and we tend to have really nice people coming along, so I expect everything to be hunky-dory, but at least there's that there. If you want to learn a bit more, then you can go to that bit.ly in the bottom right-hand corner and you can see what our full code of conduct is for that. I should check that still exists, that URL, and that it's not disappeared in some strange upgrade to the website or something. But interestingly, I'm just making sure that that's actually gone live on YouTube. I'm not sure. It looks like it has. I've got a weird error message. Let's have a look. Just double check that that's running. It says the video is. Oh, there we are. Yeah, somebody's running there, so that's good. So moving on, we've got a bunch of sponsors. Normally, I would be using most of these sponsors, but we're remote. So Rebel would normally be sponsoring our food and drink, and BGSS would normally be sponsoring the office space for us to be able to meet up in, and the alcoholic drinks. But obviously, we're remote, so still shout out to those two. Rebel are a ethical recruitment company based in Nottingham. They're awesome. So if you've got any recruitment needs, then do go and check them out. And BGSS are a consultancy. They're all over the country, but they happen to have offices in Nottingham, and we tend to go and meet up in there. So check them out as well. JetBrains, I'll talk about shortly, and my company PJG Creations, which still runs in the background, even though I'm a fully employed Avanade employee. They just sponsor the website and Zoom license and all of those things. So that's what all that's about. I mentioned JetBrains. If you tweet on the hashtag .NETKnots, then you'll be in with a chance of winning a JetBrains license. If you don't know what JetBrains do, then they create developer tools for developers. So things like Rider, IntelliJ, WebStorm, PHP Storm, ReSharper, all of those good tools, and you can win a license for 12 months for any one of those particular products if you tweet on that hashtag .NETKnots. Yeah, do that, and then we'll draw that out when I get some time. But somebody always wins, so it's good. There's a few MVPs. There's at least two of us on this call, and every month we say we'll sort Connell out with an MVP at some point. You're definitely on your way to one, so we'll do that. But Matteo and I are both Microsoft MVPs. That program rewards people who do things like Matteo is doing at the moment by speaking in the community, or myself and Connell for organizing events in the community, or contributing to open source, or helping to be able to drive things like blog posts and stuff like that. If becoming a Microsoft MVP is of interest to you, then do just send me, or I'm sure Matteo will be happy to receive a message from you as well, and we can clue you up on what's involved in that. So tonight we've got Matteo Amelli talking about lessons learned building cloud native architectures. But before he talks about that, we've not got a meetup next month because it's Easter, like 2 weeks at the end of the month. So normally we'd push it into the next week, but it's still Easter. So we're going to skip March. I'm going to go on a European tour with my family instead. So I'm sure you'll understand that there's no March meetup. But the end of April, we'll be back in person at BGSS offices with Simon Painter, who is a regular at .NET Knots. He's very good. And he'll be talking about the topic of the moment, basic machine learning algorithms. So Simon's talks tend to be quite technical as well, so suited for folks that like that. But he always brings a light-hearted element to it and makes it approachable. So well worth coming along for that if you can. And another in-person event, in case you didn't realize, I also run Knots IoT, which is an IoT and high-tech meetup. And we're in person only on Thursday, again at BGSS, where we'll be having a Raspberry Pi birthday special. So in case you've not spotted, the 29th is the leap year Day this year, and they ever so purposefully released the Raspberry Pi on the leap year. So this is like their third birthday, even though they've been out for like 10 years or 12 years or something funny like that. It works out that this is their leap birthday. So what they've done is they've supplied user groups like us that are running a Raspberry Pi event in particular with a Raspberry Pi 5 and a power supply and a case to give away at the event. So not only are we going to have some show and tell stuff, including a remote controlled car that's controlled with a Raspberry Pi, and I think there's an automated beer tender application. I'm not sure the beer will be there as part of that. And also a Oculus Quest controlled robot arm that I'll be bringing along that I normally give talks about. So there'll be that. And then there'll be a Raspberry Pi stroke IoT themed quiz. And the winner of that quiz will walk away with their hands full of Raspberry Pi goodness. So by all means, come along to that. That's going to be a good event. King Street in Nottingham, BGSS offices on Thursday. So look forward to seeing you there. And with that, I will stop babbling on and we'll switch over to Matteo. So I'm going to stop. Questions again, just come off mute and shout at Matteo. He's given us a free rein to be able to do that. If you don't feel comfortable doing that, then by all means, just stick your questions in the chat and either Connell or myself will interrupt Matteo on your behalf. Again, this session's been recorded. So if you're not comfortable having your webcam on, like most people haven't, then by all means keep it off. But for the purposes of an interactive session, if you're able to, please do keep your webcam on. You won't appear on the recording unless you start talking. Just bear that in mind. But other than that, over to you, Matteo.
Thank you, Peter. And I'm also keeping an eye on the chat. One of the things of having multiple screens, so I can have a look and pick up on questions directly. This session is about lessons learned. All right. So as I was telling you earlier, this is not a session where I'm going to talk for 45 minutes, hopefully, but you can rather stop me, interrupt me, tell me your opinion, tell me your question, anything at all is fair game. Okay. So I want to make sure that we talk about this because we're no longer in a situation like we were 20 odd years ago, where continuous integration came out and it became the only way of building software, and rightly so. Nowadays, we've got so many more options. So I want to make sure that whenever we talk about, actual real world stories, we can discuss and we can compare. I'm Matteo, I work at Avanade UK and Ireland, blog here, Twitter here, or X, whatever it's called these days. As Peter correctly said, I'm a Microsoft MVP in Azure DevOps and GitHub. And I'm here to talk a little bit about some of the things that we saw in person. Now, we, as an industry, we got a long way. Right? When we started talking about the cloud, we started talking about something that was originally very simple. Amazon S3, for example. 2006, it was something revolutionary. It was something completely different. We never saw anything like that. We asked ourselves as people, I do remember all this, but we asked ourselves, what are we going to do with this cloud thing where it's hosted by someone, we can't really control it, we have to trust someone else, and all of those things, right? S3 was just storage, obviously. But then Microsoft came on board a couple of years later. And I do remember this because somewhere in my storage unit, I still have the t-shirt. I was not a PDC in 2008. I was just 18 and I was, part-time student, if you like. But I remember talking with people. I remember going at a local event, a local community event back in the day. And I remember talking about, okay, Windows Azure, what is this thing? Why is Microsoft doing this stuff? Like the .NET services, the live services, they didn't make any sense to me back in the day. SQL services, yes, it was a hosted database. SharePoint services, fine, way of hosting somewhat web applications. It wasn't really because it was SharePoint. CRM, I never really touched CRM in my life back in the day, so I had no idea. But I couldn't fully understand it. Again, we're talking 2008, right? So we're talking about a fair bit of time ago. But I couldn't fully understand what there was until I actually started playing with it and I started building a few things with those services. And then, well, let's say that we made some progress, right? So this is the Cloud Native Foundation landscape, or the CNCF landscape for products and projects. And you can tell that S3, Azure services in general, all of those things, they not even feature here. Like probably amongst the most recognizable, you've got Dapper, you've got Kubernetes somewhere over here, there it is, you've got Keda, you've got, what else? I'm just go scanning through real quick, right? gRPC, brilliant, right? Absolutely brilliant. But all of those things, open feature, absolutely love it. I'm going to talk about it at some point in the future. But all of those things, they've all been built on top of a cloud native foundation, and they've all been built throughout the years to then become hosters or to be consumed. So we all started building on top of these and more, right? So the industry has, the complexity in the industry has increased probably 100-fold, if not even more. And at the same time, ourselves, when we're building our own applications, we completely change the way we think of them, we design them, we build them. Like 3 tiers applications used to be the golden standard 20 years ago or thereabouts. I see some nodding, very good. So 20 years ago, we thought about, okay, we've got the UI, you've got a data layer, then you've got some foundational layer. Everybody were trying to do this. Then you had some patterns. So you had MVC coming in for web application. You had MVVM for client applications. Yes, I do remember. So you can tell pretty much around those times. I used to love like the fact WPF was absolutely brilliant, and WCF. I was probably the biggest fan of WCF in my own country, because to me that was a revolutionary way of doing things. And that's where, for example, we started thinking API first. WCF was the very beginning of being API first, the concept that evolved in the cloud to today, where you have message queues and you have all sorts of integration services, and everything is API first by design. But that means that in order to get to the point where we are in 2024, some mistakes have happened, right? And I try to gather around 4 mistakes in particular, which I believe, and again, I saw them time and time again in various situations, things that I believe they happen, they do happen regularly. Now, Peter is saying that he loves MVVM. I used to love it as well, as much as I hated that, because it introduced a level of complication for a developer that was used to Windows Forms back in the day. That was completely different, and it took a long time to get to it. But we'll leave it to another day, or maybe to a DDD side chat next week. Well, this weekend, I should say. But anyway, so mistakes happen, and the mistake, like the most common mistake that I see, is about teams and organizations and projects, etc., that they want to do things in a cloud native way. They start using cloud native technologies, but at the end of the day, they don't really act as cloud native. And that is a substantial difference when it comes to modern application development. So using the most appropriate technology really makes the difference. And I'll pick up a very, very simple example: databases. Let's assume, for the sake of argument, that you need to store a SQL Server database. Okay? It doesn't matter what the database does to an extent. You are familiar as a team with the concepts of SQL Server. And I stress that SQL Server, because otherwise we could go on and talk about hosted Oracle. We could be on talking about MongoDB. We could talk about PostgreSQL. The list is long. All right, but for the sake of simplicity, let's pick up a SQL Server database. Now, in Azure, if you were to host in Azure, so I'm going to leave AWS aside, I'm going to leave, RDS, for example, aside. I'm going to leave everything else. So talking about Azure exclusively, if you were to store a SQL Server database, you have, give or take, 4 options. The first option is SQL Server on Azure VM. Then you've got Azure SQL, which I would say most of you are familiar with. Then you might have Azure SQL Managed Instance and Cosmos DB with the NoSQL API. Now, we're talking about just one database. It cannot be that difficult to find the right database technology to be cloud native for real. But alas, it is. Because if we pick up all of them, we start looking at SQL Server on an Azure VM. SQL Server on Azure is literally infrastructure as a service. So the same concept as on-prem brought to the cloud. It is super compatible, right? Because it's literally, you pick up an on-prem database, you chuck it into an Azure VM, off you go, fine. It's easier to provision because it's got its own flavor of ARM and bicep behind the scenes, but it's very much like running a virtual machine with SQL. So you have to build everything yourself. You have to maintain it yourself, etc. That's absolutely fine if you want to do infrastructure as a service, which is fine again as a cloud concept, but it's not really cloud native because infrastructure as a service comes to address the problem of on-prem to cloud. You've got some cloud native capabilities, right? You've got the hybrid licensing for cost control, for example. You've got the capability of deploying a VM with SQL configured in a certain way, at least at an infrastructural level. So there are some things that you can automate, but again, you're running in the cloud. You're not cloud native. Let's take that, off the table. Fine. Next option, Azure SQL database. Now you might think that, okay, I'm going to spin up my Azure SQL, Azure SQL Server, Azure SQL database. I'll put it in there, and then I am cloud native. Well, no, you aren't. Because unless you really think about what you need to do with your database in the cloud, then you're nowhere near to be cloud native. Because, for example, let's assume that you're running off a single database and you are running with, let's say DTUs. You're not cloud native. You are at risk of running into the same problems as traditional SQL Server hosted on-prem or on Azure VM, resource exhaustion, to name it, right? And this is where it gets, I don't want to say complicated, but there are a lot more options. You pick up a single database, or actually you want to go towards an elastic pool where you can scale up and down as needed on your resources. Is it enough? Or do you want to go even nimbler with serverless and use capacity-based models? Or are you actually running something so big that requires hyperscale? All of those questions needs to be addressed front and center if you want to be cloud native, because they will all carry their own complexity behind the scenes. And if you go, at a simpler, but also foundational level, all of these offerings, they support either vCore or DTU allocation. So which service tier are you choosing for your daemon workload? And that alone takes time, right? That alone is something that will take a lot of deliberation to get the right thing. Because remember, when you're running in the cloud, unless you're doing it cloud native fold after, then you're going to have problems. First of all, cost, right? If you go in your kitchen or bathroom, you open up your sink, you let it run. That's what happens with the cloud, right? You're going to have a huge water bill. You're going to have a huge cloud bill because obviously you deploy something, you let it run 24/7, not configured, not optimized correctly. You end up in a situation where you either over provision or you scale out so much that you're going to pay so much for things that you don't really need. So it's important as an architect to think about that. Hybrid licensing is a way of controlling costs, obviously, same way as Azure VM, or reservations. So typical example, you got an application, it's running 24/7, it is fairly predictable in terms of behavior, and it's fairly predictable in terms of loads. If you are operating on a cloud native way, then you can reserve what you know is the baseline of consumption on a 24/7 basis. So you're going to get a discount. And it's one of the ways that you can leverage then dynamic allocation. You can manage vCores, DTUs, service tiers, and all those things, right? But you can also control your bill. Peter is saying that when talking to slightly experienced but not expert customers, for instance, it's easy to end up in a lift and shift isn't cloud native debate. Well, that's because it isn't. If you're running in the cloud, you're not cloud native. You are leveraging some cloud technologies and you are making the most of this, but you're not getting all the benefits. Typical example of that, Azure SQL Managed Instance. It is a cloud native offering. It uses the same engine as Azure SQL behind the scenes. It is super compatible with legacy SQL Server though. So you have more support on the schema side compared to Azure SQL. However, You then start looking at the limitations, and you start looking at what you can do with it. And you can easily see that besides being more expensive, because there are a number of extra features behind the scenes, but you can also see that if you're multi-tenant, you can only have 100 databases per instance. And if that was not a concern for you, you have a maximum of 16 terabytes of data, for instance. That could be a deal breaker. That could be something that if you are migrating from on-prem to the cloud and you want to be cloud native, so okay, Azure, manage Azure SQL Managed Instance, absolutely fine. I'm happy to go with it because I know it, but it looks cloud native enough for me. That would be very true. But then you start doing your legwork in designing the architecture, etc. And when you build it, you realize that, oh, I can't move my production database because it's bigger than 16 terabytes. That can be a problem, right? So think about it. Think about those things. And option 4, and again, for a simple database, option 4 is Cosmos DB using the NoSQL API. So Cosmos DB is a cloud-native JSON-based document database. It's it's got vectors in there. It's not a relational database. However, it will expose an API that allows you to interact as if it was a relational database. Now, this is the Pandora's box because Cosmos DB is brilliant. It is geo-distributed. It has got throughput-based performance tiers. You can have it as provision, serverless, fully auto-scale. Geo-distribution happens with one flag in a configuration item. You got elastic scaling, you name it. But it comes at a cost. It can be extremely expensive if not configured in the correct way. It becomes extremely expensive if you don't size up your resource units, if I could correctly. They're called, you don't calculate them enough, or you don't calculate in the right way, you're going to have an expensive bill to look after. So those are 4 examples of how we have to work out what is the best way of picking up a database, a hosting database. Can we make it easier? Like, can we make it slightly easier for a team that is not, that doesn't have either the luxury of time, because sometimes it happens, you just want to release something and you want to ship. You need to ship, fine. So can we narrow this down? Yes, there is a way, but I'm going to pick up Peter's point in the chat before that. Data Explorer is also an option depending on data and solution too. Yes, there you go. Yet another option for storing data. And again, then we can go into data lake, and there's so many things, right? But keeping your options open is important. Narrowing it down is important. What I do is this usually, and now I would really like to hear from the audience. I use this wrapping logic, and we're going to use it throughout in the session. I start looking at a number of foundational items first and foremost. So, what is my performance requirement? What is my high availability requirements? Is there any specific networking configuration or requirement that I might have? Ranging everything from IP restrictions to private endpoints to VPN gateways, all those. Then I add any specialistic requirements, because not all features or not all services are exposed at all or in the same way in all regions in Azure or AWS for that. When I have an idea in mind, then before choosing anything, I start looking at what is the most managed service that I can find. And I stress that most managed service, because if you're running in the cloud, it's very, very easy to get carried away with something that might not be fit for purpose. It is very, very easy to go into something that you feel it's the right fit for today, and then in 3 years' time, you realize that it is not fit for purpose, or the other way around. You use something that you don't feel comfortable with, because over time, your roadmap says you're going to get benefit of a certain feature. Things will change, right? So it's important to find what is the most managed service that I can afford to get to, so that I can simplify things as much as possible. And the other side of the coin is obviously cost management. Every managed service comes at a cost. Make sure that you have the right cost management in place for what you want to do. However, that's not all, because everything needs to be fronted and wrapped with the best developer experience that you feel is appropriate. So we're not talking about deploying stuff automatically. If you are in this session, we are well past CI/CD and DevOps. We are talking about what is the ease of use from an unattended, from an unattended perspective of your resources. How easily you can scale up, down, out or in. How can you get the most benefit of multi-region availability zones, you name it. Those things are really important. And the developer experience makes the difference, because at the end of the day, my cat is playing with the lights. At the end of the day, it's developers that will have to use them. So developers need to be comfortable with what you're using, because otherwise you go back to fiddling with things manually, etc. Now, Peter says, and I would like someone else to be rather than Peter, out of all these boxes, networking is the biggest can of worms, and it's hard. Stay tuned for more. That's the answer. But it is true, because nowadays, yes, full stack developers and all of that, but networking can be difficult. Networking in the cloud can be really, really difficult. Like you start mixing concepts which are relatively simple, like IP clusters, subnets, etc. And then you start adding UDRs, you start adding peer networks, you start adding floating networks and all of those things. It gets complicated very quickly. So you have to be a very firm grasp of what is your networking requirement. Any question from the audience? Anything at all?
Yeah, just come off mute and shout.
Please do.
Is this board, because obviously your experience is lengthy, shall we say? This, I mean, when Azure was first announced, even the folk at Microsoft were pimping it out as a lift and shift option, which is why I mentioned that. Mainly because the services weren't fully fledged back then. Now you've got a fully cloud native section of services that replicate everything that you've got on premise. But again, sometimes it can be difficult for folks to actually understand what they should be doing, because it isn't a one-for-one mapping. If you're going from on-premise to cloud native, that is.
Oh, yeah.
Sometimes I think a hybrid approach can work, where yes, you lift and shift the bits that you lift and shift, and then as long as you've got a modular enough solution, you can start, replace your VM with a SQL Server instance on it with a managed SQL Server instance, and your business logic can now live in an Azure function, and you can split the bits off and leave the rest going. But is that still something folks should be thinking about doing today? Bearing in mind that my experience goes back to those sorts of days as well, where my head tells me that that's an option, but is that something that you would be suggesting for folks to look at?
Oh, that is my cat again touching the keyboard. Brilliant.
Spoilers from the cat.
Well, no, he actually went backwards. So it is true. It is absolutely true. And you cannot go 0 to 100 if you never used the cloud before and you're familiar with on-prem and on-prem exclusively. You can't just go full on to the cloud. And I'll give you an example of that. Azure SQL Database has got a flag that's called allow all Azure services to access this resource. Yeah. Now, what people don't understand is that doesn't mean any Azure resource that you own. It means the whole of Azure can potentially access your database. It is an extremely dangerous thing to enable, but it exists because of ease of use. You might need that at the beginning. You might need that before your configuration when you're deploying stuff incrementally. Or, simply put, it took some time to get there, right? So if you are starting, you're experimenting, and obviously, yes, you could deploy immediately a pattern of things that will deploy a fully isolated SQL Server and SQL database and all the networking and all those things, and then you cannot access that because you don't know how to add the firewall rule, or you don't know how to add the white listing of your IP to access that, to access that instance, then it's completely pointless. The point of the cloud is to be able to have a fantastic developer experience first and foremost, to get hyperscaler level scalability, flexibility, security, and all those things, but also to do it in a way that is the most applicable to your requirements. So there's no one size fits all. And that's why we looked at 4 options for a database. 3 of them are cloud native. 1 of them runs in the cloud, right? If you're not ready to go full on the cloud, it's better to be on the cloud and you get some of the benefits of that. SQL Server, for example, SQL Database, again, one of my favorite services. It gives you backups out of the box. You don't have to do anything. You got backups. That's brilliant because before working at Avanade and obviously working with the largest possible customers in the world, I used to work with SMBs, like small and medium-sized businesses. And I'm sure everybody knows that a sheer amount of businesses, even as of today, run on-prem with a server, air quotes, running somewhere in a cabinet, and again, air quotes. I'm talking about the days of Windows Small Business Server 2003 and thereabouts. So who was there remembers. And those things were never backed up. All you needed was a blackout, no UPS, you will fry your spinning hard drives, done. An organization could have been done completely. That's what the cloud flips over, right? So you have hyperscale, you have high availability, God knows how many nines, you have ease of use, flexibility, etc. Obviously, with a cost attached to it. You have to balance out what are your priorities. That's why cost management is here, which is on top of all the other things, because these can have multiple, you can have multiple answers here. You will converge towards one, but then you have to face what is the best experience for your team and for the organization. It takes effort to design and architect a very good cloud native architecture, and it takes a lot of effort to build it right, which is why there's a number of downstream conversations that will happen. But again, this leads us to the next point, which is if all you have is Kubernetes, everything in the world usually looks like a roll scale 4 nines SLA application. Because Kubernetes is complex. People love Kubernetes. It's been built for Google, Google hosted types of workloads. Google standardized on Kubernetes, but you don't necessarily have to. And I'll explain to you why. I liberally picked up this chart from the Microsoft documentation. It's a chart that I find is extremely valuable because it tells you that if you're migrating, then you are already either cloud optimized, so you end up being in the cloud native camp, the right-hand side. But if you're doing lift and shift, then it's a completely different story, which is absolutely fair, right? Like if it's a COTS app, you're running well, actually, my wife's company runs off an ERP that was last updated in the early 2000s because of Y2K. It's a big company for the size and the scale, but for them, going to the cloud will necessarily mean going to a VM. There's no other way, because the organization that built that software doesn't exist anymore. There are a few boutiques that managed to build a support system around it because there's an ecosystem used in the industry, etc. So obviously these still heavily used, but we're not talking about organizations that can start talking about digital transformation and cloud modernization. They do completely different things. I can tell you that IT is not the priority, and I can tell you that if they were ever to migrate to the cloud, it would be to a virtual machine, no question. However, if you are looking at the cloud native camp, you have a number of options. Like, first of all, do you require full control? Yes or no? If yes, and full control means absolute full control, then it's a VM. If not, we start looking at a few managed services along the way. Those you batch, Spring Apps, etc. Then you got something that is a little bit more tailored, right? And it goes your functions, etc., down to AKS and container apps. Now, if you ask me, and that is again personal opinion and lessons learned in the field, as you bash, yeah, brilliant for running patches, as the name suggests. But if you were to ask me, the sweet spot for cloud native applications are the 4 services outlined in red. because AKS, absolutely brilliant, right? You can do so many things with AKS with a stability and a scalability that is second to none. I don't think there is anything else, as you know, with the size and the adoption of Kubernetes. However, not everyone needs them. If you're running an application that has got a predictable shape of users, if you're running an application that is native, and I'm not saying native as in cloud native or whatever, but I'm saying you've got the actual application code and you can deploy it directly. You don't necessarily need 50, well, you don't need 5,000 pods. We'll see. You have a number of reasons why you don't want to go to Kubernetes. So for example, if you're just hosting a web application, a single page web application, even better, you don't really need AKS, right? You can go with AppService. If you have a couple of containers, and again, a fairly static, a fairly static use load, a fairly static cycle of updates, etc., you don't need AKS. Now, those 4 services compared to AKS, they also put containers, because we're talking about, as the name suggests, container instances and container apps. Then you've got app services and Azure Functions. They both support containers. But Functions and App Service also support hosting applications. So I'm a big fan of App Service and Functions, because you can orchestrate a very complex architecture, and you can orchestrate it with some very cool stuff, like functions are stateless, for example, but functions can also be durable. So you can have an extended state, and you can do stuff natively. You just deploy your application code, your DLLs, whatever, to App Service, and you see results immediately, bearing in mind the DNS cache. But there is one key difference that I'm going to address in a second, after I see the question. So does a lot of these depend on if you're going to stay in Azure, or if there's a possibility to go to a different cloud provider, would you consider a Kubernetes service? Thank you, Peter. Docker. If you don't need 5,000 pods, you might not need Kubernetes, because even Amazon doesn't only have EKS, they've got other services that support containers. And it's not necessarily the only way. You can even deploy .NET applications in AWS, right? Lambdas can do it, if I'm not wrong. If I recall correctly, you can deploy .NET code and other type of code to Lambdas. So it's not exactly ECS is pretty good. Well said, Peter. So it doesn't necessarily mean that AKS or EKS or asterisk KS is the only option. However, it became ubiquitous because containers alone, they are fairly ubiquitous and fairly simple to master. And then you can host them into different environments. Now, if we look at these 4 services, the key difference between all of them is scale. And scale limitations in particular. Because, as I said, not all applications need 5,000 nodes. AKS supports, oh, sorry, I'm pointing at the screen. AKS supports 5,000 nodes per cluster. Container apps, it's 5 environments per region, 20 container apps per environment, per the replicas. Here's your high availability serve. It's 3,000 containers. Do you want to support, do you want to go container instance, or do you want to go function app? Sorry, copy and paste, but 200 instances per function app. No, it's different if I recall correctly, but this is wrong. I will share the correct one after. This is a copy paste mistake. But you can have 200 instances per function app. You can have app service with 30 instances, and if you use an app service environment, which is it's a fully isolated environment for your app service where you control the hardware allocation, essentially you can go up to 100. Now, do you need all of this? Probably not, right? You might be fine with a few containers and a number of, thank you, 200 instances, Peter, thank you so much. So you would be fine with a few containers, maybe in a container group. If we're talking about container instances, like container instances will support multiple containers into a container group that you can deploy together, and you can scale to a degree. You can have container apps, and you can say, okay, I want a certain number of apps. I want multiple environments, and I want to replicate those environments. Do I need 3,000? Probably not. AKS, do I need 5,000 nodes per cluster? Probably not. So again, let's go back to it. Let's use the wrapping logic and let's try to find out, if you remember, what is the middle layer? The most managed service I can and cost management. So let's have a look at what is the best option and how the best option serves your interest best. Because I want to check what's the, what's the number on, I'm very tempted on container instances, but I'll do that later. Because you don't really need them. And AKS carries a lot of complexity with it. AKS is not easy. You have to deal with DNS, you have to deal with provisioning, you have to deal with the CNI, you have to deal with all sorts of things. It's not straightforward. If you have to get an application up and running, app services, easy enough. And then you can decide, you want to check it into a container, off you go. And you got a number of options. So there's a lot of choice there. Remember the flowchart and remember the wrapping logic. Now, any question, anything at all, because I've been talking for a long time now. Any question at all?
You wouldn't necessarily be running Docker where you are. And I think Docker is probably the answer to a lot of these, bearing in mind that Kubernetes is Docker, really. It's just like a hyperscale Docker. But so what would you need to do to your application to make that work? If you're not already in Docker, for instance, if you've got a WPF app or something like that, and now you've got to start thinking differently about scaling. It's more the scaling that is the point here, rather than the Dockerization. Even the Dockerization in itself has got its own complexities. Never mind just storage and access to services. But
and I can also add that it's not necessarily about what you containerize, because Docker has got its own, its own things behind the scenes. And if you're moving from WPF to something like an SPA, just deploy to web service, integrate some functions, and you are in a position to go live quickly and easily in cloud natively. So you can get advantage of the scaling that the cloud brings with you. Right? Those things are important, and sometimes they are overlooked because people say, "Oh yeah, Kubernetes, like that's the only AKS, that's the only thing for me because I'm cloud native." And you have to invest into a lot of things to make sure that you get a hello roll out of the gate. Now, that is not on the developer. It's worth remembering. It's not because the developer only wants that, but because organizationally, yes, you might have the facilities to say, I already have a lot of code running in Kubernetes. I already have a lot of experience in it. For us, it makes sense. And that is absolutely fine. But if you're considering something from scratch, sometimes it's not the best option there. And that's something that people tend to forget. Now, a little bit of story time. Talked a lot about sort of abstract requirements, but let's talk about an application that I saw personally. It's an application that was migrated out of a data center and onto Azure, initially as a lift and shift, but then quickly migrated to app services because it was a plain .NET application. So nothing out of the role. They could migrate it as a monolith. Then it was refactored. So they started breaking it down into microservices. And they started taking advantage of functions. And the development team was starting to build APIs around it. So the development team started, rightly so, to behave in a cloud native way. So all the interactions between microservices was done with an API. They all had their own data storage behind the scenes. They were doing DDD the right way. All of those things, absolutely beautiful to see. Honestly, a beauty to behold. However, one day this application became extremely slow. It was not unresponsive. It was not, it was not showing any sign of, oh, there's something immediately wrong. It was just slow. So troubleshooting started, and long story short, an API was the culprit because a team realized that one user downstream, a power user, a developer, they wrote a script to automate some operations. They knew that they were doing some operation, jumping back and forth. They didn't want to use the UI, and it was data loading or some sort of upload, if memory serves me well. Absolutely fine. It happens all the time. It's an API first application. It's probably undocumented. It will happen, right? Because especially if it's stuff that's been added over the years. Now, they found out that this API was the culprit because the user wrote this script which uses the API in an undocumented way. They found out by chance because they started looking at the resource usage plane in Azure, where you can see where you're using CPU and memory and stuff all out of an app service. And also, they just refactored the application to account for long-running processes. They didn't really do much more, right? Because they just took into account that if there was a long-running process, then the UI, the user experience has changed, etc. Now, they also added some telemetry, obviously, because they're important. But the thing is, the mistake here, it's not, as you might think, how they fixed that, right? They fixed it in what eventually turned out to be the wrong way, because here all they did was accounting for long-running processes. They didn't do anything more. The big issue is that they didn't realize that they were operating as a cloud-native application, API first and all of that. They didn't realize that they became a provider. If you're running a cloud-native application that is designed and built with APIs in mind, and those APIs, for however long they exist, they are not using management. And when I say management, I don't necessarily mean API management, the resource, but API management, the design pattern, then you are in a world of pain. Because in this case, it was a simple and completely benign operation. Someone that found an API and realized that they could upload their documents with a PowerShell script or something. Now, if they were running, the API correctly, this API would have had throttling, for example, built in to prevent, this issue, because it was degrading the application experience for everyone. But also, and that's even worse, they didn't have API authentication. Now, this user only uploaded stuff sequentially with a PowerShell script, nothing fancy, nothing special, nothing nefarious. However, if I were to be a malicious user, and again, security first, shift left, and all those things. If I were to be a malicious user, I have an unauthenticated write API that gives me access to something that is either ending up on the file system or gets processed or executed, even worse. Unfettered access to an API like this is a big, big problem. Think about it for a second. If I were to install something on my workload, running, cryptocurrency mining, hosting stuff in the cloud in a malicious way, any form of processing that takes advantage of resources, etc. It's a big, big problem. So observability is a day zero requirement for cloud native. And that is something that's really important, not just for troubleshooting, not just for saying, oh yeah, I got a problem, that's the API, that is the issue that I have, but it's also for proactive observability. You can spot what are going to be the areas where you will have performance issue or availability issue or anything that's going to cause you trouble. If you are designing an API, observability is key because it gives you the usage pattern, the usage behaviors. If you're designing an API, I cannot stress that enough. Take advantage of API patterns, because APIs that even are not undocumented and they will take some form of binary payload, let me tell you, they're going to be exploited. And they can be exploited in a benign way or in a malicious way. Now, if it's benign, you end up with user experience or nothing that big. In the world that we live in, where any surface of attack can be exploited, it can be a very, very big problem. That goes hand in hand with the allow all of your services, etc., to access the database. So think about it. Think about when you design an API, concepts like authentication, throttling, validation, retry logic, all of those concepts are fundamental when it comes to having a robust and safe API. Now, there's a follow-up to this, right? And I don't see any question in the chat, so I'm going to go through it. Mistake number 4, which is sometimes, actually, this is a way more common mistakes than the name will recommend. We go back to story time. A month after this issue, the same team received a larger than expected Azure bill. Now, we're not talking about a huge amount, right? It didn't bankrupt the company. It was a very simple, well, it was a simple number, let's say. It was not a big number, but it was unexpected because this application was very predictable, right? It was running in an app service with a few functions. They knew their SKU, they knew their size, they knew they were fine. They scaled up a few times over the course of the year, but all in all, it was very predictable. Now, they received a bigger than expected bill, and it caused a few raised eyebrows, let's say. Can anyone in the chat, or and again, open up the mic, guess what was the unexpected line item in the bill? Anyone?
That's a good one. I've got Richard Jonas says application insights or logging. Network traffic.
Oh, I mean, 18 new messages. I haven't seen. Oh, it hasn't scrolled down. So application insights or logging? No, it is not. But the partially right answer is Ian Powell saying network traffic.
Yeah, cross-region network transfers probably.
Not across regions. Generically, egress network traffic. And that's why we say stay within the walls. Inbound traffic, ingress network traffic is free, right? Because when you go into a hyperscaler, no matter which one it is, okay, Azure, AWS, GCP, Oracle, they all have the same model. Like ingress traffic, absolutely fine. Go, fill your boots, come on in. You're welcome. When you try to go out, it gets expensive. Now here, we're not talking about huge numbers, but I want to make you think about something. Data transfer within the same Azure region is free. Whatever you do, you are within the walls of your region, that's free. Fill your boots. You start going inter-region, Microsoft will obviously, in this case Azure, Microsoft will obviously incur some cost because moving data from, let's say, North Europe and West Europe, Dublin and Amsterdam, there is some cost. Let's say, for the sake of argument, 100 terabytes of network traffic in a month going outside the hyperscaler. So not just between regions, but anything outside. Like it can be like streaming, it can be exporting stuff. You are interacting with third-party APIs, which was the reason why that team had that massive bill, because they were interacting with a third-party API that was receiving the uploaded payload and then returning it back. Very poor design, but let's digress. So 100 terabytes a month of network traffic. And again, bear in mind, nowadays, we use a lot of traffic because traffic is very rich when you use APIs as they are. Give or take, has anyone got a rough idea, without obviously knowing it? Anybody got a rough idea of how much it will cost in a month? 100 terabytes of network traffic. Broadly. Hands up, mics off, in the chat. Lots of dollars. Yeah. How many though?
I wouldn't have thought it'd be that much, actually. In the
Give me a
hundreds.
number.
In the
Give me a
hundreds.
number.
In the hundreds, not the thousands, I would have thought.
100 terabytes. Well,
Yeah.
the answer might shock you. It's almost $77,000 a month. Uh-huh.
Wow, okay.
So besides security, right? So when designing an application, remember security. Think about it when you integrate with other APIs, other workloads, etc. Because I am seeing, like, leaving the example aside, the example is very simple and the numbers were not that big. But what I'm seeing today is a worrying proliferation of applications that use a data platform in AWS or a data platform in Azure, whatever, then, oh, no, I'm not going to use that hyperscaler. I'm going to use my hyperscaler of choice. And let's say the data platform was in AWS, and we run AKS in Azure, fine. My application runs there, but then the application also calls another service on-prem. The numbers tally up. And interestingly enough, this is the cheapest number that you can get, because that's the number that you get by running 100 terabytes of traffic from either North America or Europe outside anywhere in the world. If you look at Asia or Australia or South America, much worse. Okay, so remember, traffic is incremental, like it's billed with the first allotment is for free, and then the bigger the allotment, the cheaper Unity becomes. But 100 terabytes, which is not like, it's not an outrageous number. It's a big number, but it's not an outrageous number. 100 terabytes of network traffic in a month is a lot of money. So keep that in mind. Why is it that expensive? That is because it's one of those things that the hyperscalers can only optimize as far as the provider allows. All right. So you will still have a lot of overheads. You will still have a lot of things that are in between. You're using national infrastructure. There's a lot going on there. It is optimized if you think about it, because it works out a few pennies per gigabytes. But still, 100 terabytes is a sizable amount of data. The number is not negligible. Now, who's got the final question? I've been talking for a long time now. Who's got any final question? And I hope you enjoyed the session.
I'm waiting. I've asked lots of questions.
Come on, folks.
Has anybody come up against that data egress cost in the real world other than Matteo? Anybody seen anything like that?
I was speaking with a few colleagues today in the in the virtual office, and the answer was yes, we saw that.
Yeah. If you just do a quick search, you find bandwidth pricing in Azure, and you can see then internet egress, and there seems to be two different ones, and I'm not sure what the difference is.
Yeah.
And it says here from North America and Europe to any destination.
Yes.
And the next 100 terabytes a month is 0.0553 per gigabyte, which works out at £55.30. Like, it seems as though what they're talking about there isn't what you're talking about, I guess.
Well, it tends to be like it's an incremental calculation, right? So the first amount is free, then the second amount is within a certain allotment, and it's got a different price, and then it adds up to the end, right? 100 terabytes is one of those numbers that it is not negligible, but it is also, it's also one of those numbers that will add up in the end, and organizations will see it. Now, when it comes to pricing, and again, that is a very good point that you bring up. So it is per 10 terabytes per month, but it's per gigabyte. The price is per gigabyte.
Yeah.
So you have to calculate it per gigabyte first, and then you multiply, for example, like it adds up.
Yeah.
So that was one of the really eye-opening questions, really, because you would say, it's just network traffic, and you don't think about it in this day and age, but it actually matters, and it will have an impact in the end of your cloud bill.
Yeah, that one about cross-region data transfer can catch people out quite a lot, where just because you've got a resource group and you deploy that to UK South or something, you're not necessarily always deploying services to UK South when you put them in there. And more so, some services don't exist in that region. So you end up with one that's in the US, and then you leave it running and you don't check. And then suddenly, oh, what's all this data transfer cost about that I wasn't planning on? Oh, well, that's because you're going between regions.
Let me try to ask, and again, let's see, let's have a little bit of a play, right? A little bit of fun. We'll do this. But let me open up Copilot. Right? Let's try, right? Let's have a go. So let me see what's saying. So
We can't see your screen in case you're
Yeah, give me
expecting.
1 second. Give me 1 second. All right. So let's have it. Let's have it. Moving my mic as well so I can type. How much would it be to run 100 terabyte of egress network traffic? Thank you.
We can still only
Question
see.
come up? Nice. Let me copy this. That's all.
We can still only see your slides just in case you.
Oh, just the slides. Hang on a second.
Yep, you've shared your screen. Yeah,
I thought,
slides.
oh, I was showing the screen. Let me just share the whole screen.
VPN and private link cost a lot more than normal network. Yeah, actually, that's a really good point, and I've not looked at that, William. That's a good point.
So the number, the pure network number between with egress is this, but then you have to calculate anything else that you go through. You have to calculate if you are using, if you're going from South America to any destination, you have to use VPN in mind, etc., etc., etc.
Is that a comma? 4,487?
Yes, yes.
Huh.
Like that number, that £76,000 is obviously $76,900 is a worst case scenario.
Well,
it's obviously designed to make you think, but it's one of those things where you see you have to calculate per tier, and in this case, if you multiply this plus the egress, the ingress going in someplace else where you actually pay for ingress, let's say in a co-hosting location or something where you could pay for it, and if you have other things going on in between, like network inspection and all that, it will sum up, right? It will add up.
Oh. So my maths didn't work at all because I just took the per gigabyte number, multiplied it by 1,000.
Yeah. No, because it is tiered, right? So you got some traffic at the beginning for free, then you got a certain amount, and then another amount, and then another amount, etc. That's where it becomes interesting with the cloud.
I'm sure the calculator helps. There must be a calculator for that somewhere.
Yes, there is.
To measure it.
So, few questions. Yes, VPN and private link cost a lot more than a normal network. Yes, and again, pointing question. I brought out the big number just for the sake of, argument. But yes, like things will sum up in the end. And remember, for example, if you use VPN gateway, you use API API management, all of that, there is an inspection cost in all your request, right? So there is a cost that gets applied whenever you use traffic across services.
Yeah.
Which is really, it's really important, and things will sum up. Now, I see another question. I vaguely remember, how reliable is a region? Are there any stats available? If very reliable, high nines, is it necessary to design for region failover? Brilliant question. So there are things called availability zones, which are a physical design that Microsoft has got in their data centers, 3 data centers per location, etc. You've got availability sets, which are multiple racks, etc., in the same data center. It depends, right? It depends on what is your tolerance to risk, what is your high availability requirement, making sure that that gets addressed. Yes, a single region is very reliable, but what if the region goes down? And it happened a few times. Like if you search, you will find out that there have been situations where a hyperscaler region actually went down. So think about it. You are obviously in a very reliable environment, and I don't remember the SLAs to be honest off the top of my head. But if you are in a situation where you have to account for geographical distribution, then yes, you have to design for multi-region. And multi-region doesn't necessarily mean single geography. There are obviously caveats to all of that, but there are applications that need to be geo-distributed in nature. And one of those things is that Cosmos DB, for example, you can just geo-distribute your data with a single click. It's going to cost whatever it's going to cost, but you can do it easily. If you're doing virtual machines, then you have to look at multiple layers of high availability, region, geography, scale sets, etc. So there's a lot that you can do in order to do cloud native high availability. It depends on what you actually need. I vaguely remember there are SLAs out there somewhere, probably different resources. Yes, every resource has got different SLAs. Every resource has got a different SLA on different permutations of resources you use. Off the top of my head, if you use any virtual machine with a premium SSD, you're going to get 0.95 SLA because of the disk. That's one of the quirks, if you like. For availability, should you partition your application so that small parts where you need availability can be scaled across region and other parts where it isn't needed don't have to? So you can save on cost of scaling. Yes, you can do that. And also, as Peter says, you can also use CDN, so content delivery networks. That's another thing that you should take into account. So for example, one of the things that you can do if your database is fine with the vast majority of usage patterns, then you will find that you don't need to scale your database. You need to scale your front end. You might need to scale where you actually receive traffic. You might have to do load balancing to make sure that you have not just enough resources to cater to the resources that you got, but you also don't have bottlenecks based on the resources, on the design of the workloads. AKS for everything. Yeah, good luck with that. When you have 5,000 nodes per cluster and then you have to scale because those are not enough. Brilliant question. No, absolutely brilliant question. And I'm glad that like the number, obviously the $77,000 is not the pure, the pure cost of the traffic, but it's something that in the worst case scenario I saw on a bill, and there was a lot in there that explain it. You have data egress, you have scanning, and you're using certain types of systems in between. Everything that's got to do with traffic out of the walls will have a charge. That's the short answer.
Probably just as
All right.
as everything you do there is that cost management box and dashboarding and alerts and that side of things that folks tend to forget until they get a bill like that, and then suddenly it becomes a priority.
Yeah.
But
we go back to the point that if you use the cloud as is, you're going to your kitchen, you're opening the tap, you're letting it run. Right?
Oh.
Can you drink it? Yes, absolutely. Can you wash with it? Oh, 100%. You can even cook with it. But the bill is going to be expensive because everything is obviously metered. So you have to make sure that you keep that in mind and close the tap when you don't use it. So you're also like, oddly enough, if you like, you're also very environmentally friendly because you're also going to reduce your carbon footprint if you don't use something and you shut it down or you reduce it. Something to keep in mind.
Yeah, that's actually a really good point. If you've got a big data center and you want to cloud native, mind the cost of the person or people that are maintaining it, but the actual cost of your carbon footprint can be quite good. Get Azure to plant a tree on your behalf.
Lovely. Any further question in the chat? No, I don't see that. No. William is going to head off to a maintenance window. Brilliant.
Brilliant. Gonna get Azure bill.
All right. Well, thank you very much for attending the session. I hope you find it interesting. I will also be at DDD North this weekend. Otherwise, feel free to get in touch. I'll be happy to have to entertain any question.
Very good.
Thank you very much for having me.
Yeah, really good. Always a pleasure to have you, Matteo, as well. So
cheers. Pleasure.
Again soon. So thanks, folks, and we'll catch you in April, in person and online. Catch you then. Or maybe Thursday if IoT's your thing.
All right.
All right. Cheers, folks.
Cheers. Bye.
Yeah, there we are. I've kept Dan in case he wants to pipe up. Thank you very much, Matteo. That was good.
Oh, my pleasure. My pleasure.